All right, this is page 30 in your binder. We are going to talk about geometric sequences first. A geometric sequence is a list of numbers in which the ratio remains constant. The common ratio is the number that you multiply by over and over. So, we are going to look at 1 through 6, and we are going to determine if these are indeed geometric sequences. So, the first thing I want to tell you though is to find the common ratio, you take the second term in the list, so the second number, and you divide it by the first term. Some of these we can just look at and we know. So, in number 1, I know that 2 times 5 is 10. Check. 10 times 5 is 50. 50 times 5 is 250. So, yes, this is a geometric sequence, and 5 is the number I'm multiplying by over and over and over. In number 2, I can't just look at that and know what number to multiply. So, I'm going to take my second term, 45, and divide it by my first term, 135. That gives me 1/3. So, you have two options. You can type in times 1/3. 135 times 1/3 is 45. 45 times 1/3 is 15. 15 times 1/3 is 5. So yes, this is 1. If your brain can handle it, instead of multiplying by 1/3, you can also just divide. I can't draw a division. Divide by 3. So either way works in your brain. All right. To get from 6 to 18, I multiply by 3. 18 times 3 is not 24. No, this is not a sequence. Okay. To get from 7 to negative 14, I'm going to multiply by negative 2. 14 times negative 14 times negative 2 is positive 28. 28 times negative 2 is negative 56. Yes, this is a sequence. All right. So this one, 80 to negative 40, I'm going to divide by negative 2. Or you can multiply by negative 1/2, whichever works better with your brain. Either way, I get negative 40 divided by negative 2 is 20. Divided by negative 2 is negative 10. Yes, this is a sequence. All right, let's see, 9. Negative 9 to 36, I'm going to multiply by 4. Negative 36 by 4 is negative 144 by 4. Yes. Okay. So I just did them over and over. If the same number works, you got it. If it doesn't work, it's a no. Okay. These are geometric sequences. The directions say. So I need to figure out what number I'm multiplying over and over. So to get from 7 to negative 21, I'm going to multiply by negative 3. So 63 times negative 3 is negative 189. 189 times negative 3 is 567. Multiply that by negative 567 times negative 3 is negative 1,701. All right, let's look at this next one. I'm going to have to divide this because I don't know. So take my term 2, 768, divided by 3,072. That gives me a 1/4. So if I multiply by 1/4, I get a 48. Multiply by 1/4. You can also just divide by 4. I get a 12. Multiply by 1/4. I get a 3. All right. 8 to 4, I am dividing by 2 or multiplying by 1/2. 2 divided by 2 is 1. 1 divided by 2 is 0.5. 0.5 divided by 2 is 0.25. All right, to get from -5 to -25, I know I multiply by 5. So -125 times 5 is -625. -625 times 5 is -3,125. -3,125 times 5 is -15,625. All right, so this is easy when I just want, when I say, you know, tell me so first term, second term, third term. If I want to know the fourth, fifth, and sixth, it's quicker just to go multiply, multiply, multiply. What happens though when I tell you I want to know the 20th term? You're not going to fill in 20 blanks. That would be a lot. Instead, we're going to use our formula. The formula is a to the n, and the n, the a stands for a term. The n stands for the term number I am looking for, okay, equals A1, so this tells me that is the first term, times R. R is our common ratio. And then I go exponent n minus 1. This is what I'm looking for. And this is a minus 1, okay? That is my formula. So write this down. Pause it and write this down. I'm going to erase it to get that out of my way. All right. Write the rule for the nth term and then find A7. So first I need to identify all the parts. So I need an A1. I'm going to need an R, and I'm going to need an N. So my A1 is the first, so it's a 3. My R is what I'm multiplying over and over, so 3 times 3 is 9, 9 times 3 is 27, so I'm multiplying 3, and my N will eventually be 7. But so the first thing it wants you to do is just write the rule. So I could use anything for N as long as I do 3 for A1 times 3 and then N minus 1. So this is my rule, and now I'm going to plug in the 7. So A to the 7th equals 3 times 3, 7 minus 1. You straight up type this in your calculator, and you should get that the 7th term in this sequence is 2,187. We're going to do the same thing for number 12. I need an A1, I need an R, and I need an N. The N is going to be 7 because it tells us. A1 is a -4 because that's the first number. Sorry, that's weird looking for. And -4 times -5 will give me 20. So first I'm going to write my rule. I could use anything for N as long as I put -4 times -5 N minus 1. It's N minus 1, sorry. Okay, but now I know I want to know the N to the 7th, the N. I want to know the A to the 7th place. So -4 times -5 exponent 7 minus 1. When you type that in your calculator, you get 6,200, that is not, you get 62,500. Okay, these are going to be big answers because we're multiplying. All right, flip over to 31 for me. We're going to do this word problem together. The table to the left shows a car value for 3 years after it is purchased. Write the rule to represent the car's depreciation. Depreciation means that as the car gets older and older, it's worth less and less money. Assuming, we argued about this, assuming it's like a minivan or a Corolla, not like a super fancy car. Anyway, okay, so my rule is going to be a to the n equals a1 r n minus 1. I need to figure out what my a1 and my r are. So a1 is 10,000. So I'm going to take it. Whoop, that's not an eraser. I'm going to take that out and very skinny like. Right, 10,000. R, I take 8,000 and I divide it by 10,000. When you do that, you get 4 over 5. So my R is 4 over 5. So that's my rule. And then this tells me that and then this says, what will the value of the car be after 10 years? Okay, so I've got my A1. I know that it is 10,000. I've got my R. I figured that out. That's 4 over 5. And now my N is a 10 years. So 10. So 10,000 times 4 over 5, 10 minus 1. You type that in your calculator, and your car will be worth $1,342.18. That decimal goes on, but we're talking about money, so just round to the 100th place. Flip over to page 32. All right, I do not want you to overachieve on page 32. The only problems I want you to do are 1, 3, 5, 7, 9, 11, 13, 15, 17. That's all. You can do the whole page if you're not listening to this with sound, but hopefully you're using your big brain.